Irvin, and I'd like to talk to you about big O notation. So big O notation is a way of finding the worst case runtime for an algorithm, and this is important because we want to make sure that an algorithm is reliably efficient and will run within a certain limit regardless of the input size. The way we do this is by ignoring the algorithm's runtime for a specified input and instead considering the runtime's growth rate as the input size increases. So if the growth rate is reasonable, then we can use that algorithm for any input size. However, if the growth rate explodes after a certain input size, then that algorithm may not be useful and we may want to try and find a different one. So here is an example where I've plotted the number of the input size x with the number of operations. And here we have two algorithms, g of x and f of x, where g of x is the upper bound for f of x. And the reason is because for large inputs past r, we can see that g of x surpasses f of x for all values. So we can use g of x as an upper bound of f of x and guarantee that f of x will never be more inefficient or take longer than g of x. Another way to put this is that f of x is in the big O of g of x.